So, types of discontinuity, part 1. So, actually, there are mainly two types of discontinuity. First one is removable discontinuity. The second one is non-removable discontinuity. So, when we'll study the discontinuity, if the function is not a continuous function. Okay. So, there are two types. What are those two types? Removable and non-removable. In removable discontinuity, why we call this kind of discontinuity is a removable discontinuity? Because in this kind of discontinuity, it is possible to remove the discontinuity by redefining the function as the limit of the function is same as value of the function at given point. So that's why this kind of discontinuity is called removable discontinuity. So first we'll study removable discontinuity. Later we'll study non-removable discontinuity. So removable discontinuity. Again in removable discontinuity, two types are there. Missing point discontinuity and isolated point discontinuity. So in removable discontinuity, limit is exist. Limit is exist. Limit at given point is exist. So first type, missing point discontinuity in removable discontinuity. The first type is missing point discontinuity. So first we'll learn about what is missing point discontinuity. So by name it has missing point. That means there is no graph at that point. There is no graph of the function at that point. So from that what you can conclude? The function is not defined at that point. The function is not defined at that point. So that means here when we say that a function has a missing point discontinuity, if limit of the function has to exist and finite, but f of a does not exist. That means f is not defined at a. So that's why the graph is missed at that point. So this kind of discontinuity is called missing point discontinuity. So if you observe the graph here, so from the graph if you observe when x is approaching to a, the functional values are approaching to what? M. So limit extends to a, f of x is equal to what? M. But if you observe at a, the graph has a hole, which indicates that there is no graph. There is no graph at the given point a, which indicates what? The function is not defined at that point. So here limit is exist, but function is not defined at given point. Hence what we can conclude? Here function has a missing point type discontinuity at x is equal to a. If you take the example here, in this example, beautiful example, here f of x is equal to what I have taken, x square minus 9 by x minus 3. It has a missing point discontinuity at x is equal to 3. See here, if you find the limit of the function at given point, limit extends to 3, f of x, that is limit extends to 3 x square minus 9 by x minus 3. Here if you apply the limit, what you are getting? 9. If you apply the limit x value 3, if you substitute x value 3 there, what you are getting? Numerator 9 minus 9, 0. Denominator 3 minus 3, 0. So it is taking 0 by 0 form. So which is indeterminate form. So how to evaluate this limit? So we can't apply the limit directly because it is taking the indeterminate form 0 by 0. So either you can apply L'Hospital's rule, or by looking at this problem, numerator and denominator both are polynomials, you can approach factorization method also. So just I applied factorization method by writing 9 as 3 square. So x square minus 9 can be written as x plus 3 into x minus 3. The common factor x minus 3 get cancelled. After the cancellation, what is the left factor? X plus 3. So limit extends to 3, x plus 3. If you apply the limit, what you are getting? 6. But f of 3 does not exist. Why? Because in the given problem, what is the given function? f of x is equal to x square minus 9 by x minus 3. So to get f of 3 value, what do you have to put x value 3 in the given function? If you put x value 3 in the given function, numerator exactly 0, denominator also exactly 0. So exactly 0 by exactly 0 is a meaningless expression. So from that what we can conclude, f is not defined at 3, but it has a limit at 3, which is equal to 6. So it has a limit, but the function is not defined at that point. So what we can conclude, function has missing point discontinuity at 3. So it is clearly discontinuous because the function is not defined at given point. So because by definition f has to define at given point, then only we can discuss the continuity of the function. If it is not at all defined at given point, then f is not at all continuous. So basically by looking at that problem, f is discontinuity. F is discontinuous at x is equal to 3. But how we can, what kind of discontinuity? Missing point type discontinuity. How we can conclude? Because here limit is exist, but function is not defined at given point. So that's why we can conclude the function has missing point type discontinuity at 3. If you observe the graph, f of x is equal to x square minus 9 by x minus 3, which is equal to x plus 3 when x not equal to 3. So here x plus 3 is what? Linear expression. So here f of x is x plus 3, which is a linear expression. So the graph of linear expression is nothing but, graph of the linear function is nothing but, it is a straight line. But it doesn't contains the point 3. Okay, because x not equal to 3 now. So just you draw the graph of x plus 3, which is a straight line. But at 3 it has a hole, because f of x is equal to x plus 3, it is valid. F of x is equal to x plus 3, it is valid only when x not equal to 3. So for x is equal to 3, we can't take f of x value is x plus 3. Okay. So at x is equal to 3, what is the function has? Hole. So function is not defined at 3, but it has a limit at 3, which is equal to 6. So it has a limit at 3, but function is not defined at 3. So it is discontinuous. What kind of discontinuous? Missing point discontinuous. Okay, next. One more beautiful example. F of x equal to sin x by x has a missing point discontinuity at x is equal to 0. So how we can say, see here also, if you find limit of the function at 0, limit extends to 0 sin x by x. So we have learned this formula in 11th class only. So what is the formula for that formula? What is the limit of the function sin x by x as x tends to 0? Which is equal to 1. But if you find f of 0, if you put x value 0 there, what you are getting? Sin 0 by 0. So which is equal to 0 by 0. Again, 0 by 0 is a meaningless expression. So function is not defined at 0, but it has a limit. So same conclusion, it has a missing point type discontinuity at 0. Next type, in removable, next type, isolated point discontinuity. So in this type, limit is exist, because it is basically removable type of discontinuity. Automatic limit must has to exist. But here f of a is also defined, but it is different from limit of the function. So such kind of discontinuity is called isolated point discontinuity. So if you observe this graph here, the function has isolated type discontinuity at a. Because if you observe, when x is approaching to a from left side or right side, these functional values are approaching to what? M. So limit of the function is m. And at a, the value of the function is f of a. If you observe the graph here, clearly m is different from f of a. So therefore the function has which kind of discontinuity? Isolated point discontinuity. So if f of x has isolated type discontinuity at a, you have to understand one thing here. Isolated means what? The graph is isolatedly situated at a. See here, the graph is situated isolatedly at a. Isolated means what there? It is the point. The graph is situated alone at a. See here, just it is a point. The graph at x is equal to a, it is a point, and it is far from the remaining part of the graph. So it is situated isolatedly. That is why this kind of discontinuity is called isolated type discontinuity. Okay. So next, if you observe the example, beautiful example, f of x is equal to 2x plus 6 if x not equal to 3, it is equal to 4 if x is equal to 3, has an isolated point discontinuity at 3. Because if you find limit of the function, what you are getting? 12. But what is the value of the function? 3. Both are exist and finite, but they are different. Hence what we can conclude, function has isolated type discontinuity at x is equal to 3. If you observe the graph, so from the graph here, what we can conclude, the function has isolated type discontinuity. Okay. So here, because at 3 the graph has a hole, but the function is defined at 3. What is the value of the function at 3? It is equal to 4, which is different from limit of the function. Next, observe the one more beautiful example, f of x is equal to x square if x not equal to 2, and it is 3, x is equal to 2. This function has isolated point discontinuity at x is equal to 2, because here also same functional value is different from limit of the function. Hence the function has isolated type discontinuity at which point? At x is equal to 2. If you observe the graph, f of x is equal to x square, it is a square function. So graph will be what? Parabola. But at exactly 2, what is the function value? 3. But what you are getting, limit of the function? 4. So automatically graph must has a hole at 2. Okay. And also what is the function value at 2? 3. So this black dot denotes what? That point is denotes 2, 3. Okay. That is when x is equal to 2, function value is 3. But when x is approaching to 2, function value is tending to what? 4. So limit of the function is different from value of the function. So function has isolated type discontinuity. So in missing point discontinuity and in isolated point discontinuity, both are removable discontinuities. How? Because in both cases we can redefine the function. Redefining the function, how we have to redefine? The value of the function is same as limit of the function. So this is about removable discontinuity. Hope you understand. So now I'm going to explain non-removable discontinuity.